Hello, Namaskar, good morning, and we shall take today order of reaction and molecularity of a reaction. Okay. Yesterday, in the previous video, what we discussed was, we discussed the rate law and rate constant, and for a general reaction that was AA plus BB is equal to CC plus DD. And we have written the rate law, that is R is equal to K E raised power X B raised power Y. So, in this rate law, the power of concentration term X and Y, okay, these are the terms which indicates that how the concentration of A and B is sensitive with respect to rate of reaction. Okay. These X and Y indicates that how much sensitive the reaction is with respect to A as well as with respect to B. Okay. So, this X and Y, the sum of this X and Y in rate law expression is called the order of reaction, the order of that reaction. Okay. So, how can we define order of reaction is the sum of the concentration terms, the sum of the power of the concentration terms in rate law expression is called order of that reaction. Okay. Order of reaction. So, order of reaction for a particular reaction, it may be 0, okay, the powers, okay, the sum may be 0. Sum may be 0 means what? The concentration of reactant do not affect the rate of reaction. Okay? Means whether the concentration is low or high, if the order is 0, it means the rate of reaction is unaffected with respect to concentration of reactant. Okay? Likewise, the order may be 1, 2 or of course 3, and sometime it may be fractional as well. So, order of reaction may be 0, 1, 2 or fractional value numerically. Okay. So, this is what is called order of a reaction. It is quite simple. This is the sum of the powers, and these what these powers are showing us, these powers of concentration term A and B are showing that how much sensitive the rate of reaction with respect to the concentration of A and B. If you are changing the concentration of A, then it will change, the rate of reaction will change according to this power X. Okay. So, this is how we can understand order of a reaction. The another term which is important if we are considering order of reaction is the molecularity. Okay. Molecularity of a reaction. And molecularity of a reaction, and yes, the order of reaction cannot be determined by seeing the stoichiometry of reaction. Yesterday we also discussed this point, and we emphasized especially that it is an experimental value. Order of reaction is an experimental value. So, now the molecularity of a reaction. So, molecularity of a reaction means the number of molecules or number of moles which are taking part in an elementary reaction is called its molecularity, and it can be determined by seeing the stoichiometry of that reaction. According to collision theory, what we see, the molecule must collide to convert into the product. Okay. According to collision theory, what it states that the molecule must collide each other to convert into the product. Okay. So, if the molecules are striking to each other, then the possibility of striking the molecules, the maximum number of molecule which may strike at a moment or which may strike simultaneously, okay, maybe 2, 3 or not more than that. Okay, because more than 3 molecules strikes at a moment, at the same moment or simultaneously, it is quite very rare. Okay, the number of reacting species, that reacting species may be ions, atoms, or of course molecules taking part in an elementary step which must collide simultaneously to convert into product is called molecularity of that step or molecularity of that elementary reaction. Okay. Elementary reaction means the molecules which are taking part in that reaction must collide each other. That is what is called elementary reaction, and elementary reaction always gives us product. Means elementary step or elementary reaction means the reactant will definitely going to convert into product. So the molecularity, let us take some examples. Maybe the reaction may be unimolecular. Okay, unimolecular. Okay, unimolecular means the number of molecules which are taking part is 1. Okay, if we are heating ammonium nitrate, okay, it will break up into nitrogen and water. So here only one molecule is taking part in this reaction or in this elementary reaction, to be precise. Okay. So unimolecular reaction. Likewise, bimolecular reaction means 2Hi, means you are taking hydrogen iodide and giving some heat or energy, then it will break up into hydrogen gas and iodine gas. Okay. So in this elementary reaction, the number of molecules taking part is 2, hence it is a bimolecular reaction. Okay. Trimolecular means yesterday we also discussed this reaction. Trimolecular reaction, 2 molecules of nitric oxide and 1 molecule of oxygen taking part in reaction and getting nitrogen dioxide. Okay. So in this elementary reaction, the number of molecules which are taking part is 3. Okay. Hence it is a trimolecular reaction. Okay. But the molecularity of reaction is greater than 3 is very rare. Okay. Means why very rare? Because the number of molecules which are striking simultaneously will exceed number 3. It's quite impossible or it's quite very rare. So molecularity of a particular reaction may be exceed up to maximum 3. Okay. 3 is also a rare example, but yes, sometimes it is there. Okay. Let us see these reactions. Okay. These are the reactions in which what we can see N2 plus 3H2 converting into 2NH3, 4HBrO2, 2S2 and 2Br2 we are getting, KClO3 reacting with 6 moles of FeSO4 and 3 moles of H2SO4 and converting into product. Okay. So by seeing these reactions, it seems like a molecularity of this reaction is 4. Okay. Which is quite impossible. Molecularity here it is 5, here it is 1, 6, 7 and 3, 10. So striking 10 molecules at a time, okay, it's quite impossible. So in these reactions what is happening actually, these reactions are multi-step reactions, means these are the reactions which are not happening like this. Okay. In this reaction there are more than 1 steps. Okay. In first step that is what happening, in second step this is what happening, and in each step we are getting some intermediate. Okay. In each step what we are getting, some intermediate, and that intermediate then may react with another molecule and getting into final product. Okay. So all that is called mechanism of reaction. The number of steps involved in a particular reaction is called its mechanism, and each step is an elementary reaction. Each step is an elementary reaction, because molecularity more than 3 is quite impractical, or what we can say, it's quite almost impossible. Okay. There is no physical significance of molecularity more than 3. So that is why what we say is the molecularity of an elementary reaction may be maximum 3. Okay. So, this we should take care. The chemical reaction which proceed through more than one step are called complex reaction. Okay, means these all are complex reaction. Okay, complex reaction means these are happening more than one step. Okay, so let us see the slowest step. Okay, in multi-step reaction there are, see this reaction. Okay, this is a reaction where H2O2 reacting with iodide ion in alkaline medium to get water and oxygen. So, the rate of this reaction will be d minus d H2O upon dt is equal to K2 H2O I minus. And by seeing this rate law expression, what we can say, the order of this reaction is 2, 1, 1. Overall order of reaction is 2 and it is 1 with respect to H2O2 and 1 with respect to iodide. Means X is what? The order of reaction with respect to A, Y is what? The order of reaction with respect to B. Okay, and the sum of both is called the order of overall reaction. Now see the mechanism of this reaction. Okay, in this mechanism what is happening? First, in the first step, H2O2 reacting with iodide ion and getting H2O and hypoiodate ion. Okay, and this is the slowest step. This is the slowest step, and slowest step of a reaction is called its rate determining step, because when the reaction will complete, the slowest step will determine. If a race is beginning, okay, there are so many racer who take part in that race. Okay, some completes the race within maybe 1 minute, but some other person, okay, who is the last one, will complete the race in 2 minutes. So when the overall race will complete in 2 minutes. So that person who is taking 2 minutes is determining what? Is determining the reaction when it is going to complete. Okay. So likewise, the slowest step in a reaction will determine the rate of overall reaction. The rate of overall race is determined by that last person. Okay. When that person will finish the race, then only the management will say that okay, the race is completed. Am I right? So this is how in a reaction the slowest step will determine the rate of a reaction, because the reaction will complete when this step will complete. All other steps that are fast step, of course, like in the second step what is happening, H2O2 reacting with hypoiodate ion and getting again H2O and iodide plus oxygen gas, and this is a fast step. So this will finish. Okay. So this is the step which will determine the rate of that reaction, and it is called rate determining step. Okay. So now see, the molecularity of both the steps are 2. Molecularity of this step is 2 and molecularity of this step is also 2. Am I right? So for overall reaction, however it is appearing, the molecularity is 3, but striking even 3 molecules is also very rare case. Okay. Striking 2 molecules, yes, it's quite very often, and sometimes the striking may not required. If one molecule is there, it will just break up. It's like in ammonium nitrate it is happening. Okay. So collision theory, however, says that molecule must strike, but it's not required sometime even. Okay. So this is how we can understand the molecularity and order of reaction. Again, molecularity may be determined by seeing the stoichiometry of the reaction, stoichiometry of that elementary step. Okay, and but the order of reaction can be determined only on the basis of experimental results. By just seeing the stoichiometry, we cannot determine the molecularity of the reaction. Am I right? So in this step, this hypoiodate ion is what? This is what is called an intermediate. and intermediate is quite unstable, will take part in the next step and will finish the reaction to get the final product. Okay. So, however, in this reaction, in first step also we are getting product, in second step we are getting also product. Okay. But here this hypoiodate ion will take part in the next step and then we are getting more product. Okay. So, like this is overall reaction. This is an elementary step, this is an elementary step, because in elementary step what is happening? We are getting the product. Okay. For this step, these both are also product only. However, this is an intermediate, will take part in the next step, but for this particular step, of course, this is product and reactants are getting into the product. Okay. So, the molecularity is 2, molecularity is 2. Okay. So, like that we can understand the molecularity. Molecularity can be determined by seeing the stoichiometry of the reaction, but order of reaction is a practical value or experimental value. So, we can differentiate molecularity and order of reaction. Number of reactants undergoing simultaneous collision in an elementary step is called molecularity. Okay. But the sum of power of concentration terms in rate law expression is called order of reaction. Molecularity is, of course, theoretically we can tell it's a theoretical value, but order of reaction is practical value, experimental value. Molecularity cannot be 0. Okay. Molecularity at least it will be 1, but order of reaction may be 0 as well. Molecularity cannot be fractional, am I right? But order of reaction it may be fractional as well, am I right? And determined for a molecularity is determined for an elementary step. Okay. For an elementary step, but order of reaction is determined for overall reaction. So, these are the differences between molecularity and order of reaction. Okay. Some crazy point we can discuss here, like law of mass action. You might have heard about law of mass action, which we discussed previous year in equilibrium. So, what it states that the rate it gives the rate on the basis of stoichiometry of the reactant. Law of mass action gives us the value of rate on the basis of stoichiometry of the reaction. But rate law, what it states or what it gives us, the rate on the basis of concentration of reacting species. Am I right? Rate law gives a mathematical expression which gives the actual rate of reaction observed experimentally. Okay. Law of mass action, that is a quite theoretical discussion, I would say, but rate expression is quite practical expression. Okay, or experimental expression, experimental studies. Okay. So, these are some crazy points which we should remember about rate law and law of mass action. So, that is all about order of reaction and molecularity. Okay. You might be getting the points. What does it mean? The basic difference, order of reaction is experimental value, but molecularity is a theoretical value. Okay. That is what the conclusion is. Molecularity is determined for a particular step in a multi-step or complex reaction. Okay. But order of reaction is determined for overall reaction. Okay. So, these things we should take care of. So, that is enough for the day. Happy chemistry. Keep watching videos and of course subscribe the channel. Thank you very much.